We continue our algebra review by learning how to factor different algebraic expressions. So far we've been focusing on learning how to expand an expression, namely we started on the right hand side of this example with the parentheses x minus 2x plus 2. We multiplied them out and obtained the factored out form x squared minus 4. However, we now want to reverse the process and learn how to factor an expression, namely to break this x squared minus 4 into a product of two simple linear parentheses, namely in this case x minus 2 and x plus 2. In this section we're going to be focusing on three simple techniques that are, however, probably the most common techniques used in calculus, and later throughout the semester we'll pick up a few other techniques. We start with the first technique, which is the technique that should trump all of them. You should always look out to factor out first any common factors that appear. So the first technique is called factor out common factors. So let's look at an example. Let's say that I have the expression 2x to the fourth minus 6x cubed plus 4x squared, and we would like to factor this expression. We first try to identify if there are any common factors present in all terms. That is, I'm looking at the 2x to the fourth, negative 6x cubed, and the 4x squared, and see is there anything in common that these three terms have that I could factor out. Well, there's certainly an x squared present in all terms. There's an x squared here, an x squared hidden in the x cubed, and then again one in the x to the fourth. So I know there is an x squared in common in all three terms. And now I should also look at the constants. Well, the 4, the negative 6, and the 2, they all have a 2 in common. So I factor 2x squared. Now the question is, what remains? What should I write here so that when I multiply by 2x squared I get 2x to the fourth? Well, I should multiply it by x squared. That will give me the 2x to the fourth. Moving on to the next term, I copy the minus. What should I multiply 2x squared by to get negative 6x cubed? Well, I need a 3 for the constant, and then what's left over is an x. 2x squared times negative 3x gives me negative 6x cubed. And finally, plus, what should I write here in order to get 4x squared when I multiply it by 2x squared? The only thing missing is, of course, the 2, and I have now factored out the common factor. So this is the first technique, and we again use it to basically make the expression simpler, because now I can focus on this quadratic expression here, which I will then use other techniques to further factor. Namely, let's look at the second technique. We're going to factor expressions of the form x squared plus bx plus c by using a so-called sum and product technique. So let's look at an example just like the one above. Let's say x squared plus 7x plus 12. So the important part about this technique is to notice that the coefficient x squared in this particular form here is 1. This is really important. This technique does not work unless the coefficient of x squared is 1. If your coefficient is not 1, you could always divide out by or factor out, force factor sometimes the coefficient of x squared, and see maybe you can still use this technique, but most of the cases you will probably not be able to use it. So we're always on the lookout for expressions that have integer coefficients here, and because that will make things easy for us, and the coefficient of 1 for x squared. What does this technique rely on? Well, I'm looking to basically factor my expression into, say, a parenthesis of the form x plus r and a parenthesis of the form x plus s. And we're going to notice that if I multiply these parentheses out, so let's expand using our usual technique, namely I will get an x squared plus s being the constant times x, and then plus r times x, and then finally plus r times s. So when I combine these, I want to combine these two terms because they both have a factor of x. I will have s plus r multiplied with x plus r times s. And now this is the idea for this particular technique. Notice that this expression here is in essence what we have over here. We have x squared with the coefficient of 1, and then we have 7 instead of r plus s, and 12 instead of r multiplied by s. So in order to be able to break this expression here into two simple parentheses, the product of them, what we need is to find, in essence, r and s. So we're going to be looking for two numbers, r and s, that add up to the coefficient of x. So we're looking for s plus r to equal the coefficient of x, in this case that's 7, and we're looking for two numbers, r and s, the same numbers, so that when I multiply them, I get the free coefficient, namely 12. So now we try to think of, give me two numbers that multiply to give me 12 and they add up to 7. Well, this is easy. We can of course think of two such numbers, namely 3 plus 4 gives us 7 and 3 times 4 gives us 12. So this expression can now be factored into x plus 3, x plus 4. Alright, so checking, we get x squared plus 4x with 3x gives us the 7x, and 3 times 4 gives us the 12. So we have in fact found the correct factoring form. Let's look maybe at another example. Let's say we have x squared plus 4x plus 3. We want to factor this expression, so we're looking for two numbers, r and s, that add up to the the coefficient of x, namely 4, and multiply, so s times r needs to equal to 3. So can we think of two such numbers that when we multiply them we get 3, and add them we get 4? Well, the 3 is made out of for example 1 times 3, so I have s to be 1 and r to be 3. The order of course doesn't matter, it's just a name. So now this we know factors into x plus 1, x plus 3. We of course want to check that we made the correct factorization, so we get x squared, 3 plus 1 gives us the 4x, and 3 times 1 gives us the 3, so we do have the correct factored form. Our last technique for this part of algebra review is to learn how to factor differences of square. We're of course going to use the formula that we did use in the previous review part, a squared minus b squared, which we now know can be factored, right? This is what we actually showed, into a minus b times a plus b. So when we look at an expression such as x squared minus 9, we're realizing that this in essence is a difference of square. We have x squared minus, and 9 can be written as 3 squared. Of course x now is a, and our 3 is now the b in the formula, and we recognize the a squared minus the b squared. Knowing a squared minus b squared formula turns into a minus b times a plus b. We just have to write out a, namely x minus b minus 3, and a x plus b, namely plus 3 in this particular case. Let's look at another example. Let's say we have 1 minus x squared. Okay, we now think, do we have a difference of squares? And again we do, because 1 can be written as 1 squared. So there is, of course, a very nice trick that we should remember, that 1 is the same as 1 squared, and thus I recognize that I do in fact have a as my 1 and b as my x. So now there is no need to change the order of anything, just write down a minus b times a plus b. So in this case, a is 1 minus b is x times a, which is 1 plus x. Sometimes students get confused with this 1 minus x squared and they want to change the order. There is absolutely no need to change the order here. You can view 1 as a and x as b and simply write out the formula a minus b, a plus b. Let's now focus on some more examples. We've learned the 3 techniques that you need to know, and really they are the most common ones in calculus. So let's try to get a little bit more practice with these techniques. So let's start by looking at the example x to the 4th minus 4x squared. So looking at this example, remember the first technique trumps everything. You always want to see if you can make your expression simple by factoring something that they have in common out. In this case, we notice there is an x squared that we can factor out. What remains in the first term? Well, what should I multiply by x squared to get x to the 4th? That would be x squared. Minus what remains once I factor out the x squared, that would be the 4. So notice now I have the x squared, I've cleaned up the expression, and I'm left with the simpler parentheses that I now need to factor for further, namely x squared minus 4. Well, I recognize the x squared minus 4 as x squared minus 2 squared. This is a difference of squares where a happens to be x and b happens to be 2, not 4 but 2. So now when I write out the factored form, I will get a minus b, so x minus 2, times a plus b, so x plus 2. All right. Let's look at, say, another example. So the expression x squared minus 5x plus 6. Now, we can't factor anything out that any common factor out, so that technique doesn't work. This is certainly not a difference of squares. I have 3 terms. So the only technique that I can use is the sum and product formula. So what I'm looking for are 2 numbers, an r and an s, so that they add up to -5 and they multiply to give me 6. Now, given that one of them is negative and the other one is positive, clearly at least one of them will have to be a negative number. So we want to be careful here. You want to start by looking at the 6, and you want to think, what does 6 break into? What 2 numbers, integers, multiply give me 6? That could be a 2 times a 3, and there's another option. It could be a 1 times a 6. Now, these would be the pairs of number that make up the 6, but I now also need to think about the sign, because when I try to pick, say I pick 1 and 6, if I were to add these 2 numbers, I certainly don't get -5. So let's try. Maybe one of them should be 1 and the other one should be -6. What if that was the combination? Well, certainly when I add them up I do get -5, but when I multiply them I get 6, not negative. I get -6, not the 6 that I have here. So we need to play with the signs a little bit, and here's a big clue. The 6 being positive tells us that either both numbers are positive, the product of 2 positive numbers is positive, or that both numbers are negative. So I needed to have both numbers negative, and now when I add them up I realize -1 plus -6 is certainly not -5, so this is not the right combination. So I'm going to look at the 2 and the 3. That's where my answer will lie from. So what happens when I make both the 2 and the 3 with a minus. When I multiply them, I get the 6. That's correct. And when I add them, I get negative 5. So this is my choice of numbers that I want to use. So now my expression x squared minus 5x plus 6 will factor into the, sorry about that, will factor into the, did it again, x plus negative 2 or x minus 2, and x plus negative 3 or x minus 3. Alright, so let's continue and look at some more examples. So let's say I have the example x squared plus x minus 12. So we're looking again at finding two numbers, an r and an s, that add up to 1, and an r and an s that multiply to negative 12. So given that the negative 12 is a negative number, we know that one of the numbers will have to be negative and the other one will have to be positive. Now there's a few choices here of numbers that we can have. We can have 1 times 12, we can have 2 times 6, and we can have 3 times 4. Those are the choices that I have that make up the 12. I know one of the numbers needs to be negative and the other one positive, so that I get a negative product, and when I add those numbers up, I need to get 1. Now these numbers are too far apart from each other, so my choice will have to lie with the 3 and the 4 because they're 1 unit apart. Which one should be negative? Which one should be positive? Well, let's see. I have the 3 and the 4. If I make the 3 minus and the 4 stays with a plus, then when I add them up, I do get the positive 1. And when I multiply them, I get negative 12. So this is the correct factorization. So let me write it down. I will have x minus 3 and then x plus 4. Alright, let's do a final example. Let's say that I have 4x squared minus 25. Now, because I have two terms, there's definitely not this sum and product formula. There's nothing in common that I can factor out. So my only hope is this a squared minus b squared formula. Let's rewrite first the expression so that we clearly see who's my a and who's my b. Now, in this expression, it's only the x that's being squared. The 4 is as a constant, and in order for the formula to work, I need to have everything squared minus everything squared. So I need to identify the correct a and b. So the question is, what should I write here inside the parentheses? So when I square it, I get 4x squared. Well, that's going to be 2x, because when I distribute that square across the parentheses, I get 4x squared. And finally, what should I write in this parenthesis? So when I square it, I get 25. I should write 5. So now I have my a and the b, and I can just use the formula. So I get a minus b, so 2x minus 5, and a plus b, 2x plus 5. As you can see in this section, we learned 3 simple techniques of factoring, and the nice part about these techniques is, well, if one doesn't work, you have a limited number of techniques to think about. Like in this case, I knew, well, maybe it didn't look like a very simple a squared minus b squared formula, but because I had a limited number of techniques, I knew the other one didn't work. That gave me a good hint. It had to be the a squared minus b squared formula.